TTL Computer II. Today we're going to be testing our arithmetic and logic unit card, and we are all ready to go. This is already plugged into our testing jig, and I've powered this up. And just as a little bit of a info as to how I start this up is when I'm plugging this in for the first time, I plug the board in and I completely shut down the current on my power supply. I plug in the board, I plug in the power supply, and then I slowly bring up the current just to make sure things look okay. And if it would give me the opportunity to shut that down if the looks like we had a short, but we don't. So I do a couple level continuity tests, right? I build the first board, I get all of the components on it, the sockets and things without the chips. I'll do a continuity test. Then I'll put all the chips in and plug it into the testing jig again and do the low voltage test like I explained, and test the continuity there. So I go through the continuity test a few times again to make sure that we don't blow up any chips or any boards, which we don't want to do. Okay, so I posted the test plan on the community pages, and this is it. And you can see again we have all of our check marks done, and this is a rather extensive plan. It's a 2-page test plan. So, but you can see we have all of our checks done. So, spoiler alert, our ALU card has passed its testing. So that was a good thing and a pleasant outcome. So what I'm going to do, when I started, I did a couple of tests that weren't on our test plan, and like our other testing, I'm not going to go through the full test plan. I'm just going to give you, just going to run through elements of the test plan to give you just a feel for how the testing went. But one of the things that I started out with that wasn't in our test plan was just to do a simple OR test, and this will just allow us to validate that all of the bits are working correctly in the ALU. So to do that, I set the ALU operation to OR, which is ALU 2 and ALU 1, and we say A and B are both 0. So what I'm going to just go through here is just do each of the bits, right? We see that the output is, we see those progressing through the output. All right, this is our A argument. Do the same for our B argument. All right, this is an OR, so we're not seeing anything new here, obviously. And then I'm going to bring the A argument back to 0. All right, and then we're going to go a bit at a time here, and all of our bits are going off. So that's just a brief OR operation just to confirm that all the bits are wired correctly, and they are. Okay, so I'm going to turn our operation down to 0. Okay, so now we're going to start our formal test plan. So that was just an OR test I began the test with. I'll add that to the test plan so we have a record of it. And all right, so we're going to start our official plan now. So we need to initialize. So we want A and B to be 0. We want all of our ALU operations and our flag in, flag to be 0. And they are. And now we want to clear the carry flag. And we do that with an logical OR operation. We'll clear the carry flag, and I'm going to clock that in. And then I'm going to bring our ALU operation back to 0. So now we can check the flags. And so we have the negative, we have the not carry flag, and the Z flag. And this is where we're going to use that high-tech logic tester. We have 0, 1, and 0. And that's what we should have. 0, 1, and 0 on the flag. So that's the negative flag, the not carry flag, and the not 0 flag. All right, so that has initialized our, cleared our carry flag to start our test. And where are we here? Okay, so now we're going to do an increment test. And we're just going to set A to 1. And we're going to set the operation to increment. And that is ALU flag control 0. And that's our first good result, right? So we're using an increment operation, increment A by 1, and that's 2. All right, so that's passed. And what I'm going to do now is do a flags update. So our flags update bit is already enabled, is negative, active low, so that's enabled. I am going to clock that in. Okay, and now so we should have our flags should be 0, 1, and 1. That's 0, 1, and 1. So that's negative, not carry, and the 0 flag. Okay. Now let's try go on to the decrement operation, and we're going to keep A at 1, and decrement is ALU 0, 1, and 2. And we have A as 1, we decrement that, and our result is 0. So that's a positive, another positive test. Click the flags in. So now we're going to do an addition. And here we want A to be 1 and B to be 3. B is 3. And the add operation is just ALU 2. And the result should be 4, right? We have A is 1, B is 3, and our result is 4. So that's a good test. Now we're going to do, I'm going to get the flags in there. So now we are going to do A minus B with a borrow. So we want to have A is going to be 4. B is going to be 1. B is going to be 1. And that should be ALU 1 and 0. 0, 1, 2 is off. Okay, and the result should be 2, right? So that's 4 minus 1 is 3. And we have a borrow because of the carry flag being cleared, but the meaning in the flag reverses for subtraction. So the flag is clear, and that means we have a borrow. So the result is 2, and that's a good subtraction with a borrow test. Okay, now we're going to do an and. We want A to be 1 and B to be 3. And the AND operation is ALU 0 and 2. 0 and 2, and the result should be 1, right? 1 and 3 ANDed together is 1, and that's correct. Okay, we can do we'll do the OR test. What the heck? A is 4, B is 3, and OR is 110 on the configuration. So 4 and 3 is 7, so that's a good test. And now we can do an XOR. And we'll use A will be 1 this time. And B is 3, and it is. And XOR is 0, 1, 0. So we have 1 and 3 exclusive OR is 2. And that's what we have. So that's a good XOR test. And then let's do a final addition with a carry out. So we're going to have A as 1, and B is going to be FF, FF, and our addition is just going to be ALU 2. It's our addition operation. And so we have FF plus 1 is 0, and that's overflowing, and that's what we have. And let's do flags in. Now we'll check our flags, and that should be, again, it's the negative flag, not carry, and the 0 flag. And that should be 0, 0, 0. And that's 0, 0, and 0. Okay, so that is, remember, not carry is active low. So we saw that that's 0, and that means we have a carry out in this operation. Okay, all right, so that was, we ran through half of our test, and there's another page to go through, but we're not going to run through that whole thing. But so that is a flavor of how the testing went. One thing that we just might do is just show you that our negative flag works, because that was a test I omitted from the plan as well. So let's just do a quick negative flag test. And we want to, all right, so let's do this. We're going to set A to be hex 80, B to be hex 1, and we want to do OR, which is 1, 1. All right, so we have hex 80 plus a hex 1 is a hex 81, and that's what we see. And we want to do a flags in, and then we want to just check our negative flag, which should be high. And it is. All right, so that's just a successful test of our negative flag. Okay, so we've run through all of the, pretty much most of the elements of the test to see how the test proceeded. And yeah, this was a big win. There's a lot going on this card, right? Just as a reminder, we have the two ALU chips, each one doing 4 bits of the 8-bit operation. We used our GAL chip here that we programmed that saved us 6 chips on this card. And yeah, there's a lot going on. This is probably our most elaborate test plan that we've had thus far. And I noticed the other day when I was looking on our community pages that I made an error on this board. And I don't know if anybody else noticed it or not, but you might want to pause this video and then go back and look at the circuit board picture and see if you noticed what the omission is. But I'll tell you right now what it is I missed a bypass cap right here on this chip. And yeah, I'm a little bothered by that. I thought about just soldering in on the back of the board the bypass cap, but I became more uncomfortable with the thought of soldering that in and having it just sitting on the back of the board. I became more uncomfortable with that than the idea of having the bypass cap be omitted. It should be fine. We have quite a lot of bypass caps on here, and there's one not too far away on the adjacent chip. So that should be fine. Okay, so this was our next to last card. We have one more card to produce. It's kind of incredible. When we started this process out, after doing our digital simulation, all our design work and getting to the kickoff of the build, I was really a little apprehensive that we had a lot of building ahead of us, and I had never done printed circuit board designs or anything, but it's proceeded pretty well. And we're up to our last card, which is going to be our control card. And then we have our backplane board to do. So these next two cards are going to go, we had a hiccup here because we were delayed by a week waiting for those dip chips to come through for the ALUs. But I'm going to need more time on these last two cards because there's just extra work that I need to do, and I want to be extra careful about the designs. I want to have to put some extra testing elements into the boards to allow us to do adequate testing, and potentially want to use a GAL again on our control circuit card to eliminate a few chips. And it's also going to be, the GAL is good because it'll allow me to have some programmability in a key area of the card that if there is happen to be a mistake, we might be able to correct it in the GAL and software. So anyway, that's it for today. And until next time, thanks for watching.